In our previous video, we established the definition of autonomy and what's leading to its proliferation in society. And we connected that with how COVID is becoming an accelerating force in the change of technology. Today we're going to talk about an important aspect of autonomy, which is the concept of scalability. Scalability is kind of the baseline of machine learning. And so that's a popular industry buzzword that's getting a lot of press, and very few people know how to define it or apply it to their everyday world. So what we're going to do today is draw the connection between machine learning and scalability, and we're going to establish scalability as the baseline for competency in machine learning and the application of machine learning. Scalability is the idea that you can add to a network of smart systems or smart machines, and the newest addition to the network will automatically learn what all the other machines know. And so when we think about scalable systems, we think about fleets. It could be a fleet of smart devices or a fleet of vehicles. As a new member to the fleet is added, that newest member can connect to the network and learn all of the learnings from the other machines. And that means that you can grow or you can scale a network really fast simply by adding more units of machines to the network. Examples of that are driverless vehicles. Driverless vehicles do an enormous amount of computational effort in scanning of the environment to create real 3D maps of their environment. When a new vehicle is added, does that new vehicle have to go walk the same path as the previous vehicles to know the same things? Or can it download all that knowledge from the other vehicles into its own internal mapping system? If it can download that internal mapping system, that's an example of scalability. Another advantage of scalability is that you can add capacity as you need it. And that helps with cash flow and it helps with investment. So if at the offset of a system deployment we only need 20 or 30% of capacity, we may choose to only deploy 20 to 30% of the machines that we need. Over time, as capacity grows, we'll continue to add to the fleet until we've reached our 100% maximum, at which time we're finally making our full investment in the system. This delay of cash flow helps with the business case around scalable technology. A simple example of scalable technology is what you might have in your home. Sonos speakers are a scalable technology. The first one that you set up takes a little configuration and time, and you have to teach it certain things about your home or your environment. As you add subsequent speakers, each speaker joins to the network, and it becomes part of the sound system in the home, and it automatically finds the app in your phone. And so that's an example of a scalable technology right there in your home. An industrial application of scalable technology are driverless vehicles. Let's take driverless forklifts as an example. As we add subsequent forklifts, do we have to teach the next forklift about all the inventory systems, the positioning systems, and the mapping systems surrounding its environment? Or does that newest member to the fleet automatically benefit from the learnings and the computer programming that's happened to the initial members of the fleet? We've already established that scalability is one of the most important aspects of autonomy and autonomous technologies. We would challenge that any business or individual making a significant investment where scalability can be applied should consider that at the front end of system design and development. Anytime technology is being added to or a fleet is being scaled up, we would expect that scalable philosophies of design should be applied, and that will maximize the business case and the investment scenario for anyone making the investment. In our next video, we're going to talk about an important design consideration of scalability, and we're going to link it back to how that ultimately influences autonomous technology.